Hello Year 9, your Do Now task for today is an Educate quiz. The task is linked below. You can also find the link on your Go for Schools page. Today's lesson is on thermal energy transfers. So this is your title. Please make sure it's underlined at the top of your page. So, what is the difference between heat and temperature? So temperature is a measure of how hot or cold something is, and it affects the speed at which the particles in the substance are moving, whilst heat is a transfer of thermal energy. The higher temperature an object has, the more thermal energy it stores. But there are other things that can affect the amount of thermal energy stored in an object. For example, if we look at these two diagrams, both beakers of water are at the same temperature, whatever that temperature may be. We can see that by the thermometers. However, the larger beaker will have a higher thermal energy store than the smaller beaker, because each particle must be moving at a certain speed to get the same temperature. But there are many more particles in the larger beaker, which is why there is a larger thermal store for the beaker on the left than there is for the beaker on the right, because your temperature is sort of the average energy that each particle has, whereas your heat is the total energy that that substance has. So, thermal energy always flows from a high temperature object to a low temperature object. Can you pause the video and try and explain these three scenarios now that you know that statement? So, you would run your hand under a cold tap when you get burnt, because the thermal energy would flow from your hand, which now has a high temperature, to the cold water, which is a low temperature. So you are transferring some of that thermal energy from your skin to the water, which will help the burn be less severe. Example 2, your can of Coke warms up if you hold it too long. So that is the thermal energy going from the high temperature of your hand to the lower temperature of your Coke. Example 3, you should keep the oven door closed while cooking. So we keep the oven door closed while cooking because otherwise the thermal energy from the high temperature air particles in the oven will be transferred to the air particles in the room, and that means that the temperature of the oven will decrease as the thermal energy stored decreases. Okay, can you have a go in your books at describing the clothing for these two situations? I would like you to talk about the appearance, the materials, the colour, the size, the shape, the things you might wear it, but either in the Antarctic or on a nice sunny beach. When you were talking about the clothing required for these two situations, you might have thought about insulation. Now, insulation slows down that transfer of thermal energy from the object with the higher temperature to the object of the lower temperature. In these pictures, you can see some examples where we are using insulation to keep the thermal energy in, and some objects where we're trying to keep the thermal energy out. So if you've put a cold drink in your flask, you're trying to keep the thermal energy out. If you put a hot drink in your flask, you're trying to keep the thermal energy in. We also use this in our houses, for people, in both scenarios. Okay. Conduction. A conductor is a material that lets thermal energy flow through it. It has high thermal conductivity. So this is the opposite of an insulator. It's allowing that thermal energy through, whilst an insulator is trying to slow it down. Can you write down some examples of conductors and insulators that you know, please? Next thing to think about. Why does this wok have a wooden handle but a metal body? Pause the video and have a little think for 30 seconds. So this wok has a wooden handle because wood is an insulator, and you want to slow down the transfer of heat from the hot pan to your hand so that you can handle it easily. However, you wouldn't want a wok that is completely made out of wood. You need a metal body because you do want to transfer thermal energy from the flame on your gas hob to your food to make it cook. Have a little think about which person is going to burn their hand first. The person roasting the marshmallow with a glass rod or with a metal rod? Try and include as many key words in your answer as possible. You may wish to use insulator, conductor, transfer, thermal energy. Okay, so looking at the glass rod and the metal rod, you can see that the particles move and vibrate faster when they are heated, and they collide with the particles next to them, meaning that thermal energy is transferred through the solid. However, each individual particle does not move position, they just move from side to side. If we look at the left diagram for the glass rod, we can see that the transfer of this thermal energy is much slower. The colour red is very slowly passing up towards the hand, whereas if you look at the metal rod, the thermal energy is passing much quicker, and that's because it's a better conductor of thermal energy. So here is another example. So we've got our metal rod and we're heating it with a Bunsen burner. To begin with, our atoms are cooled, and that is depicted by this blue colour. Slowly, the atoms nearest the heat source, or the Bunsen burner, gain more energy and begin to vibrate faster. This vibration spreads through the material as the particles collide with one another. Have a little think about what happens if you heat up a gas and why. The classic example of this is a hot air balloon. What happens when we heat up the air in a hot air balloon? Okay, so if we heat particles up, they move faster. They also begin to spread out more, and this lowers their density. So, as the gas is heated, the particles move faster. This means that they spread out more and the gas becomes less dense. Because the gas is now less dense than the gas around it, that area of gas begins to rise. It's exactly how lava lamps work. You have a bulb at the bottom of your lava lamp that gets very hot. That then heats the liquid above it. That liquid becomes less dense than the liquid around it, so it rises. As it reaches the top, that liquid now becomes cooler. The particles move closer together. They become more dense, so then they sink. This is also seen in the Earth's mantle. So this image on the left, you can see that the liquid mantle that's between the Earth's crust and its core has convection currents. This hot molten rock rises as it becomes hot and less dense, and then it cools as it becomes more dense. And it is this convection of the Earth's mantle that causes tectonic plates to move, which results in the formation of volcanoes and earthquakes. Here is just another image, once again showing you we have a heating coil in the bottom right, and as the particles heat up they become less dense, so they rise because they're less dense than the things around them. As they get to the top they begin to cool, and that's when they become more dense and they sink. So this describes convection for you. your plenary, could you answer these 4 questions for me and upload your answers to Teams? Thank you very much.